نبينا محمد وعلى آله وصحبه أجمعين. This is section 8.2, Systems of Linear Equations in 3 Variables. We studied system of linear equations in 2 variables in the previous section. Now here, if you look to this equation, you have 3 variables, x, y, and z. We call this equation linear. Why it is linear? Because the power of x is 1, the power of y is 1, the power of z is 1. So if the powers of all variables is 1, then we call it linear. So this is a linear equation in 3 variables. In general, this is the form ax plus by plus cz equals d. A, B, C, and D are real numbers. Could be any real number. Not all zeros. Some of them could be zeros, but not all of them. So this is a linear equation in 3 variables, x, y, and z. What is the graph of this linear equation? The graph would be a plane in 3-dimensional space. So it is a plane like this. This is a plane. This is another one. Okay. And there is another one also, this one. So there are 3 planes here in this figure. The process of solving a system of 3 linear equations. Now we will talk about system of 3 linear equations. We will have 3 of these equations. What would be the solution of the system? As usual, it would be the point of intersection. Can the 3 planes intersect? Yeah, these 3 planes, for example, intersect at this point. This is the point of intersection. So what is the solution of the system? A solution would be an ordered triple in this case, not ordered pair, ordered triple. So x, y, z, ordered triple like this. This would be the solution. And this ordered triple should satisfy all the equations in the system. The solution set would be the set of all solutions. Let us first learn how to check, how to show that this ordered triple, for example, is a solution of the system. Notice that this is an ordered triple. Ordered means this is always the value of x, this is always the value of y, and this is always the value of z. What you write first should be the value of x, second y, third z. So if you replace x by -1, plus 2 times 2, which is y, minus 3 times -2, if you add, you should get 9. So -1 plus 4, this is 3, plus 6, this is 9. So this equation is correct. Now here, 2 times -1 is -2, minus y would be another -2, plus 2 minus 2 means minus 4. Is this equal to -8? Yes. Negative x would be 1. 3 times 2 would be 6. Minus 4 times minus 2 would be plus 8. Is this 15? Yes. So this ordered triple satisfies all the 3 equations. So it is a solution of this system. Please check also that this ordered triple is a solution of this system. Let us check this one. This is x, this is y, this is z. So x is 4 minus 2 times y, y is 1. 4 minus 2, is it 2? Yes. 2 times x means 8, plus 3 times 1 means 3. Is it equal to 11? Yes. Y is 1 minus 4 times 2. 1 minus 8, is it equal to -7? Yes. Notice the question here, determine f. So if the ordered triple does not satisfy any of the equations, then immediately it is not a solution. To be a solution, it has to satisfy all the three equations. So in this case, it's a solution because it satisfied all the three equations. Now, the main point here is how to solve the linear system in three equations, okay, three variables also. The main point would be to reduce the system to two equations in two variables. So you have three equations in three variables. You will reduce it to two equations in two variables. How would you do that? You take two different pairs of equations and you eliminate the same variable from both pairs, the same variable. Let us try this exercise. Here I have three equations. If we want to eliminate x, okay, so we have three equations and three variables. Let us decide to eliminate x. If we eliminate x, then we have to choose two equations, say equation 1 and equation 2. How to eliminate x from equation 1 and equation 2? Look, here you have 2x, here you have x. So you can multiply equation 1 by -2. If you multiply equation 1 by -2, you will have -2x minus 2y plus 2z equals -1 times -2, that's 2. And equation 2 is 2x minus 2y minus 5z equals 7. Now, if you add these two equations, x would be cancelled, and I will have -4y, 5 minus 5 plus 2 is -3, 7 plus 2 is 9. So I can call this equation 4. And you choose another two equations, for example, equation 1 and 3, or you can choose 2 and 3. Okay, so either you choose 1, 3 or 2 and 3. And you eliminate also the same variable. You have to eliminate x also from 1 and 3. So this is 3, 4x, and this is 1. How can we eliminate x from 1 and 3? I multiply equation 1 by -4. If you multiply equation 1 by -4, you will have -4x, -4y, plus 4z equals -4 times -1, that's 4. And equation 3, you write it as it is. And now you add the two equations again. X would be cancelled. -4y plus y would be -3y. 4 minus 2 would be plus 2z equals 11. And now this is equation 5. So that's how you reduce the system of three equations from that consists of three equations into a system of two equations in two variables. So again, you select two different pairs of equations and you eliminate the same variable. Then the second step, you solve the resulting system of two equations in two variables. So now you have two equations, 4 and 5. So solve 4 and 5 together. Now to solve 4 and 5, I will eliminate one of the variables. If you look, I have -3, -4 coefficients of y, 2, -3 coefficients of z. So I will multiply equation 4 by 2, 2 times equation 4. And I will multiply equation 5 by 3, 3 times equation 5. If you multiply equation 4 by 2, you will have -8y minus 6z equals 18. If you multiply equation 5 by 3, you will get -9y minus plus 3 times 2, 6z z equals 11 times 333. Now if you add, you get negative 17y, and z would be cancelled, and 18 plus 33 is 51. So y would be 51 over negative 17, which is negative 3. So now you have the value of y. What should you do? Now you use y value, you put it in equation 4 or 5. I'll use equation 5. From equation 5, negative 3 times y is negative 3, plus 2z equals to 11. So 2z would be equal to, this is 9. If you take it to the other side, 11 minus 9 is 2. So z is 1. So now I have the value of z and the value of y. This is what he meant when he said solve the resulting system of two equations in two variables. The result is an equation in one variable, and then back substitute to find the value of the second variable. So I found the value of the second variable. Now use the values of the two variables, y and z, to find the value of the third variable by back substitution. So use y and z in any of these equations. For example, I'll use equation 1. So from equation 1, what do I have? I have x plus y, but y is negative 3, minus z, but z is 1, equals negative 1. So this is equation 1. Negative 3 minus 1, this is negative 4. If you take it to the other side, it would be 4. 4 minus 1 is 3. So the solution set consists of the ordered triple, x first, then y, then z. Then you can check your answer that this ordered triple really satisfies the three equations, or you can use mode 5, 2 in this case, and you enter the coefficients of the three equations. So 1, 1, negative 1, negative 1, then 2, negative 2, negative 5, 7, then 4, 1, negative 2, and 7. And of course, if this question, so x is 3, y is negative 3, z is 1, so my answer is correct. If this comes in the exam, it's better for you. Of course, you have to show all these steps, but it's better for you to have the solution in front of you. So if you get, for example, in the first step, in this step, that y is not negative 3, you know that there is a mistake, and you try to find your mistake and correct it. Okay, so this is how we solve systems in three variables. Now, a question. When you solve a linear system in three variables, here I eliminated x. We choose to eliminate x. Now, which variable should I eliminate first? This could be a question, and the answer, it doesn't really matter. Okay, you can eliminate any variable, but you need to look to the coefficients and see which one is easier to eliminate. I prefer y here. I could eliminate y easily here, because if you multiply the first equation by 2 and you add with the second equation, y would be eliminated. Also equation 2 and 3, if you multiply y by here, the equation 3 by 2, also y would be eliminated. So you just look to the variables, okay, and you choose one of them, the easiest one to eliminate, and you go ahead and solve the system. Another solution, and please pay attention. So what I'm going to do, not to make mistakes, I'll find the answer using the calculator first. So 5, negative 2, then negative 4, then 3, then 3, 3, 2, negative 3. It is ready in the form. Negative 2, 5, 3, 3. Now what is the answer? The calculator says that the answer is negative 1, x is -1, y is 2, and z is -3. All right, I know that this is the answer. Now let me try to solve the question. Now, which variable to eliminate? Coefficients of x 2, 3, 5, coefficients of y 2, 3, 5, coefficients of z 4, 2, 3. Well, I like the coefficients of z more because this is 4. I can make this 4. Okay, I will eliminate z. Eliminate. Now these are the steps. Eliminate z from equation 1 and equation 2. Now to eliminate z from equation 1 and equation 2, I will keep equation 1 as it is. But I will multiply equation 2 by 2. Because the coefficient of z in this case would be 4. If you add, you have 11x plus 4y, 6 minus 2 is 4. This would be cancelled and you will have -3. So this is equation 4. Good. This is the first step. The second step, eliminate also z from equation 2 and equation 3. You can take 1 and 3. It is up to you. Okay, I will take 2 and 3. Now the coefficient of z here is 2, here is 3. So I will multiply the coefficient of equation 2 by -3. So I will have -9x, -9y, minus 6z equals 9. I'm multiplying equation 2 by -3. You can tell him what's going on. You can say here -3 equation 2 plus 2 equation 3. Okay, you can tell him what you are going to do. Now, equation 3, I will multiply by 2. I will have -4x plus 10y plus 6z equals to 6. I multiplied equation 3 by 2. Now, if I add, I will have -13x, and 10 minus 9 is 1. 6 minus 6 would be cancelled. I will have 15 here. Now this is equation 5. So this is the second step. Now the third step, solve equations 4 and equations 5 together. So I will solve equations 4 and 5. Let me look to equations 4 and 5. I have 11, -13, coefficients of x. I have 4, 1. So I will multiply. I will take equation 4 as it is and multiply equation 5 by -4. So I will write equation 4 as it is. 11x plus 4y equals to -3. But I will multiply equation 5 by -4. So I will have -4 times -13. This will give you 52. So 52x. Then -4 times y, minus 4y. Then -4 times 15. This is -60. Now I add 11 plus 52 would be 63. So I have 63x. And this would be cancelled. And here, -3 and -60 would be -63. And now you can solve this equation for x and get x equals -1 because -63 over 63 is -1. Let me check, is this correct? Yeah, x is -1. That's good. So let me continue. Now I have x. Now how to find y? I use equation 4 or 5 to find y. I'll use equation 5. So from equation 5, what do I have? I have -13 times x, but x is -1, plus y equals to 15. That's good. Negative 13 times negative 1, this is 13. If you take it to the other side, 15 minus 13 is 2. So y is 2. Is it correct? Yeah, y is correct. Good. Now, what about the last one? How to find z? Okay, to find z, I have to use one of these three equations, any one. So, for example, I will use equation 2. Okay, so 3x plus 3y, I'll say from equation 2. 3x, x is negative 1, plus 3y, y is 2, plus 2z, 3x plus 3y plus 2z equals negative 3. This is equation 2 equals negative 3, isn't it? Yes. So what do I have? Negative 3, these two cancels, and 2z would be equal to 6, goes to the other side, negative 6. So z would be negative 6 over 2. That's negative 3. Is this correct? Yes. So the solution set consists of x is negative 1, y is 2, z is negative 3, and that's the answer of this question. And now I can just erase this solution, and 100% my answer is correct. Please, I know it needs some time. You need to practice a lot. Any mistake you do here, it will affect your answer. That's why you have to be very careful when dealing with equations. Also do this one, please. Solve this one and this one. A lot of exercises for you. Let us discuss here which variable to eliminate. Here, that's easy. I will choose to eliminate z. You can eliminate y, easy. Eliminate x. This is very easy, this example. Here, I think z is nice. You can choose z because 1. You remember, if one of the variables has coefficient 1, immediately it would be very nice. You can eliminate this variable easily. So for example, 1 with 2, I can multiply equation 2 by negative 4, x would be eliminated. 2 with 3, I can multiply equation 2 by negative 2, x again would be eliminated. So in 7, you can eliminate whatever variable you like. Here also, it's easy. Please eliminate one of the variables. Well, sometimes the coefficient of one of the variables is 0. So one of the variables is not there. For example, if you look to the second equation here, there is no z. 2x minus 3y. Where is z? Well, the coefficient of z is 0. Here, there is no x in the third equation because the coefficient of x is 0. So how to work in this case? Well, in this case, you choose the equation with a missing variable. Okay, for example, equation 2, z is missing in equation 2. So look here, equation 2 does not contain the variable z. Equation 2 does not contain z. So what to do? What would be the idea? Take equation 1 with 3 to obtain a second equation that does not contain z. Take 1 and 3 and eliminate z from them. So we can eliminate z from equation 1 and equation 3. Okay, this is one way. Somebody could say, okay, x is not there in equation 3, so I will take equation 3 and I will eliminate x from 1 and 2. That would be also fine. Let us solve the question. Z is eliminated from equation 2, so I'll take equation 1 with 3 and try to eliminate Z. I can eliminate Z by adding. So equation 1 plus equation 3, immediately if you add equation 1 and 3, you will get x. There is no x here to add with, plus 10y plus y would be 11y, minus z plus z would be cancelled, and 12 plus 2 would be 14. 12 plus 2, 14. This is equation 4. Now, equation 2 and equation 4 are two equations in two variables. So you can Now you can solve equation 2 and equation 4 together. So it would be easier if one of the variables is eliminated. Look to equation 2 and equation 4. It is easy for me to eliminate x because the coefficient of x here is 1. The coefficient of x here is 2. So I will multiply equation 4 by -2. So I can say that equation 2 minus 2 equation 4. This is what I'm going to do. So equation 2, I have 2x minus 3y equals to 3. This is equation 2. Now equation 4, I will multiply by -2. So I will have -2x minus 22y equals -2 times 14, -28. If you add, x would be eliminated, and I will have -25y. -28 plus 3 is also -25, so y is 1. Now I have y, so from equation 2, this one, I can replace y by 1 to find the value of x. So 2x would be 3 plus 3, 6, and x would be 6 over 2, which is 3. Now I have x and y. I can go to any of these three equations to find z. Of course, 1 and 2, because z is not in equation 2. So for example, I can use equation 3, 10y minus z equals to 12. Y is 1. So if you take z to this side and 12 to this side, z would be -2. So the answer, the solution set, consists of x3, y1, and z is -2. I can do something. I can just check my answers in equation 1. Okay, equation 1, x plus y plus z equals to 2. Is this correct? X is 3 plus y plus z. 4 minus 2, 2. Correct. So my answer is correct. Please try to solve this example. And also here you have another way, discovery, another way to solve this example. Okay, please read it and try to do it and compare your solutions and answer which one do you prefer. Okay, there are different methods to solve a linear system. Also this one, you can do it by yourself. Of course, here what do you have? X is eliminated from equation 1. So eliminate x from 2 and 3. You will have two equations in y and z. Solve them, find y and z, and then use equation 2 or 3 to find the value of x. Here also the same. And here also the same. Now, a system of linear equations in 3 variables represent, as we mentioned, 3 planes. The 3 planes could intersect at one point, but not necessarily always. Sometimes the planes may have no common point of intersection, no intersection of the planes. They could be all parallel, or two of them parallel and the other one is not. So we could have inconsistent system. We could have systems with no solutions, okay? Or we could have systems with infinitely many solutions. But we will not discuss these systems here. We will study inconsistent and dependent systems in chapter 9. So at 8.2, we will have we will not consider dependent systems or inconsistent systems. And a nice example here, a nice exercise, find the quadratic function. Find this function. How would you find this function? X squared x are there, but if you find a, b, c, you will be able to find this function. So if you know that a is 1, b is 1, c is 1, the quadratic function would be x squared plus x plus 1, for example. But I need to find the quadratic function whose graph passes through these 3 points. So what is this? This is x and y. What is this? X and y. What is this? X and y. Now the graph of this function passes by all of these 3 points. What does it mean? It means that this point satisfies this equation. So I put y -4. Y is -4. And I replace x by -1. Now a times -1 squared plus b times -1 plus c. This will give you what? -1 squared is 1 times a minus b plus c equals -4. So this is equation 1. So every point will give you an equation. The second point, 1 and -2. Y is -2. X is 1. So 1 squared times a would be a. 1 times b would be b plus c. So the second equation, a plus b plus c equals -2. This is the second equation. Now the third point will give you a third equation. Y is 5 and replace x by 2. 2 squared is 4. So 4a plus 2 times b plus c. So the third equation, 4a plus 2b plus c equals 5. Now you have 3 equations. You solve this system. You choose one variable. For example, I will eliminate b here. If you add 1 and 2, you can eliminate b. From 1 and 3, you can multiply 1 by 2 and eliminate again b. You have 2 equations in 2 variables, which is a and c. You solve and find the values of a and c. Then you use one of the equations to find the value of b. Once you have the values of a, b, and c, you write the answer. You write y equals 2x squared plus 3x plus 4, for example. The last question would be similar. We need to find the equation of the quadratic function, this one, but he will not give me 3 points like this. He will give me a graph. So here is the graph, okay? So we select 3 points that appears in the graph. So I can see, for example, that this is the point 5 and 0, and this point is 3 and 0, okay? And I can see this point also 4 and 1. So I select 3 points on the graph, okay? If I am not sure that the point 4, 1, 4, 5, 0, maybe 5, 0 and 3, 0 are not there, okay? If you choose a point, you must search for a point. I think this point would be okay, and this point would be okay. So 5, 0 may not be accurate, and 3, 0 may not be accurate. So I'll choose 2 and -2, and 6 and -2. And now you have 3 points on the graph. You can solve it similarly like we did here in question 21. This is the end of section 8.2, and inshallah next time we start chapter 9. Thank you, and if you have a question